Hello, we are here to introduce the spanning tree and Prim's algorithm. Within the video, we will look at the brief history of the creation of Prim's algorithm and later rediscovery. Its characteristics make it different from other algorithms that can also be applied to the spanning tree, like Kruskal's algorithm. A step-by-step guide on how to use it effectively and how it is applied, and lastly, on how it can be applied within the modern world. Before we can look at Prim's algorithm, we must look at what it applies to in relation to mathematics. The answer is that it relates to two things, a greedy algorithm and a spanning tree. A greedy algorithm has a distinct characteristic towards it. Its intended use is to find the best immediate solution while finding an answer, and it applies to the entire graph. However, on occasions it can find a solution that is not entirely optimal. A spanning tree contains all of the vertices within a graph, utilizing only some of the edges, and contains no cycles. Prim's algorithm uses both of these to find a minimal spanning tree for an undirected graph. This means that it finds a graph where all the vertices are connected and the total weight of the edge is minimized. It was developed in 1930 by mathematician Wojciech Jarnik, and later rediscovered both by computer scientist Robert C. Prim in 1957 and Edgar Dijkstra in 1959.
Prim's algorithm can be applied to many facets of life, ranging from jobs that have heavy reliance on length to software applications that generate mazes and puzzles. The minimum spanning trees were first studied for ways to lay out electrical circuits within cities. They needed to minimize the amount of spanning that was used to install wires between houses. Prim's algorithm was applied to find the lengths that would have the least rate, making shorter lengths of wire, hence minimizing cost and redundancy. Typical problems were faced on designing internal computer networks. These networks needed to optimally arrange the connections between computers while faced with the constraint of location and installation cost. The shorter the total cable length of the network, the lower the installation cost would be. Finding the shortest total cable length on a computer network can be classified as a minimal spanning tree problem. The application of Prim's algorithm has been implemented into modern-day hardware, where the performance of computing units, such as CPUs, can be analyzed and tested through running Prim's algorithm, where the speed of calculations done by each unit can be compared to one another, giving this algorithm a major role in hardware development. When tested on CPUs, the algorithm itself is memory-bound, with a low computation requirement. Hence, its performance is highly dependent on the organization of memory storage and memory access patterns. Prim's algorithm can even be used in programming. This example is used to both create a graph of nodes and connections with the createGraph class, and within the algo class, implement Prim's algorithm to create a minimal spanning tree. While the code has no specific purpose, it can be applied to many other variations of software to create mazes, puzzles, and plans for roads or electrical work.